Hi Ducks, welcome back to another edition of DuckFlix. Today we are going to continue our understanding of decimals with problem solving. Let's take a minute to review our lesson 5.8 scale. By the end of this lesson, we hope that you will be able to solve multi-step decimal problems using a work backwards strategy to perform operations. Take a minute to pause the video and record your beginning of the lesson scale and goal. Let's take a look at an introduction to the working backwards strategy. Okay, and it's going to make a lot more sense once you see some examples. You're probably thinking that sounds silly. So we will demonstrate our understanding of inverse operations by using this strategy to problem solve. Now, just as a reminder, inverse operations are operations that we use, such as addition and subtraction. These two are inverses. And multiplication and division are also inverse operations. They are opposites of one another. So I know in this unit we are working in decimals, but to warm up so that you understand the idea of the working backwards strategy, we're going to start with a simple example. So if you see below here, we are going to start with a problem where we have an unknown amount of cherries. We don't know how many, so it's a big question mark, mystery. And we know that when we add it to 20 grapes, we have a total of 60 pieces of fruit. If we wanted to do these operations backwards, okay, because the first one is the normal way, okay, this is the traditional way that we would solve. We would work backwards. Right here is the backwards way to problem solve. This is just a strategy. We could start with the total pieces of fruit that we know. We could subtract the 20 grapes that we also know to find our missing piece, which is the amount of cherries. And we know that 60 minus 20 is 40. So if we were working backwards and using this strategy, we would come up with 40 cherries. Let's take a look at our first I do problem with decimals. And remember, we are problem solving, so we are going to be using the cube strategy. So Coach Tate spent $15.99 for one basketball and two sports drinks. Okay, and two sports drinks. The sports drinks, each keyword, cost $1.79, and we have sales tax that was $1.22. Coach Tate also used a coupon. We have a coupon, and we know coupon means discount of 50 cents off his purchase. What was the cost of the basketball? So I'm going to show you how we would work using a traditional method and then how it would look working backwards. So we always want to start with our unknown, and this is the cost of the basketball. And then we are going to add that to $1.79 times 2, and the reason it's times 2 is because we have 2 sports drinks, so we need to multiply. And then we are going to add $1.22 because we have the sales tax that we need to figure in. And we are going to then subtract the coupon, because when we are using a coupon, we are getting a discount of 50 cents. And that, all of this, and that will equal $15.99 total. So now this is where the work backwards strategy comes in. Okay, you can kind of think of it as like a little flow map. So if we're going to work backwards, we're actually going to start with our total of $15.99. And $15.99 is the total cost. And if we're working backwards, now we're not going to be subtracting the coupon. We're actually going to be adding the coupon of 50 cents because he would have paid more without the coupon. So we need to add in the 50 cents that he would have paid. Then we're going to subtract the $1.22 for the tax. And we're also going to subtract the $1.79 times 2 for the sport drinks. And when we do that, this is going to equal $11.69. Okay, so that is the cost of the basketball. And if you wanted to check your work, you could insert 1169 and you could do the operations, the regular operations, and you would get a total of $15.99. Okay, let's look at the WeDo. So for this problem, Miss Walker, spent a total of $30 at the grocery store on one package of chicken tenders. So $30, one package of chicken tenders, bag of potato chips, and, keyword, 3 giant chocolate chip cookies. Okay, we have the tenders costing $8.95. We have the chips, it's a jumbo bag, costing $7.25. And I always like a deal, so I brought a 75-cent coupon for the chips. Now, luckily, it was food, so there was no sales tax. No sales tax. The cookies each cost the same amount. So we have cookies, each cost same amount. How much did each cookie cost? So we're going to start out by thinking to ourselves, we have an unknown number of 3 cookies. And we're going to add the $8.95 for the tenders, chicken tenders, buffalo style, spicy style, delicious. Okay, next we're going to add in the $7.25 for the jumbo chips. And then we're going to subtract 75 cents because I had a coupon to save money for those chips. When we have a coupon, we're subtracting because it's a savings. And all of this is going to equal $30 total that I spent. So now let's go ahead and do our little flow chart. And let's talk about the inverse operations and working backwards. So when we work backwards, remember we're going to start with the total, which is the $30. And if we're working backwards, we're going to add in the coupon. Remember, we're using the inverse operation. We were subtracting the coupon. Now we are adding. And the inverse operation of adding the chips is to subtract $7.25. And then we need to subtract the chicken tenders. Which is $8.95. And that will equal $14.55. Well, that's a really expensive cookie. Well, wait a minute. I want 3 cookies. I want I want to know how much each costs each. So this is the cost of 3 cookies. So what I'm going to need to do now is I'm going to need to divide by 3 in order to get the cost of 1 cookie. So we have $14.55 divided by 3 cookies. And I should get a total of $4.85 for each cookie. They better be absolutely delicious. All right, now it's your turn. Go ahead and pause the video and we will check our answers when we return. And we're back. So last week, Mr. Smith, our music teacher, or now our Dean of Discipline, spent a total of $20. He spent $9.95 for tickets to the pancake breakfast, $5.70 for pictures with Santa, and the rest for 2 snowman ornaments that were on sale at the holiday shop. He also had a coupon for a 25-cent discount for arriving before 8 a.m. to the event. If each ornament had the same cost, how much did each ornament cost? So I'm just going to go ahead and do this quickly and show you your answer. We should have started out with our unknown for the 2 ornaments. And we're going to add in $9.95, add in $5.70 for pictures with Santa, and we're going to subtract the 25-cent coupon for arriving early for a total of $20. So now let's use our flow map. And let's go ahead and work backwards. Mr. Smith has $20. We're going to add in the money from the coupon, because remember, we're using inverse operations, so we would be adding the 25 cents. Then we're going to subtract what we added before, because these are the inverse operations of addition. So we're going to subtract $5.70, and we're going to subtract $9.95, and we're going to get $4.60. But remember, this is for both ornaments. We want to know ornaments. I can't spell. Okay, both ornaments. So if we take that number, $4.60, and we divide by 2, we get $2.30, which is the cost of each ornament. Okay, each ornament. And remember, if you want to check your work, make sure that you did this correctly, you could put back in the $4.60, and if you added up all the costs and then subtracted your coupon, you would arrive at $20. Okay, that's all for today's DuckFlix. I hope you learned a little bit more about the problem solving using the backwards strategy. Go ahead and record your final scale for this lesson now that we've gone through it, and we will see you in class tomorrow.